With the increased possibility of radiation exposure and the ever-present threat of nuclear terror attacks, the United States and the world must have the capability to respond quickly and effectively. Should there be a mass casualty incident involving radiological or nuclear materials, cytogenetic biodosimetry is a proven technique for providing individualized absorbed radiation dose estimate. Cytogenetic biodosimetry uses circulating peripheral human blood lymphocytes to estimate absorbed radiation dose by analyzing the extent of chromosomal damage. The Oak Ridge Institute for Science and Education in Oak Ridge, Tennessee, helps the U.S. Department of Energy and the National Nuclear Security Administration close a critical gap in our nation's ability to respond to a mass casualty radiation incident by operating the Cytogenetic Biodosimetry Laboratory.
This lab is really unique because it is one of the nationally funded laboratories that performs dose assessment. It provides personalized radiation dose assessment in case exposure happens to some people. And this individualized dose assessment will be really helpful for clinical and medical management.
When energy associated with ionizing forms of radiation is transferred to atoms and molecules in human cells and tissues, it causes damage by breaking the chromosomal DNA, and the damage induced is proportional to the type and amount of absorbed energy. Most of the chromosomal DNA breaks induced by radiation are correctly joined, but some breaks are not. Misrejoining of two broken chromosomes after radiation exposure results in one abnormal chromosome known as a dicentric chromosome, and the dicentric chromosome number increases with increasing dose of radiation exposure. This strategy for dose estimation is accurate because lymphocytes, a type of white blood cell, express the damage regardless of either external exposure or internal contamination. The process used by ORISE's cytogenetic researchers provides for the identification and scoring of abnormal chromosomes, which ultimately allows researchers to quantify DNA damage.
Once we determine the number of dicentric, we use a calibration curve, then we plot it into a calibration curve, and then we estimate the dose. The dicentric chromosome assay is the gold standard. It's been in clinical practice for more than 50 years. It has a low background. You can find one dicentric in 1,000 cells. It's independent of age or gender. It's very specific for ionizing radiation exposure.
The testing takes 3 to 4 days to complete after the receipt of the blood samples at the CBL. With the existing capability, 100 samples can be processed in 1 week's time. There are many advantages to the cytogenetic biodosimetry process. It is standardized and scalable with relatively low costs and provides a refined dose estimate for patients who need aggressive or more specialized medical care. Cytogenetic biodosimetry can also detect or confirm false positives and false negatives in cases of erroneous doses estimated by physical dosimeters. The cytogenetic biodosimetry data are useful to decision makers and public health officials who assess the magnitude of exposures. For more information regarding the Cytogenetic Biodosimetry Laboratory, please contact the Radiation Emergency Assistance Center training site.